There we go. Awesome. All right. Okay, so how's everyone doing? Oh, wait, resume share. Wait. There we go. All right, how's everyone doing? All good? Awesome. Okay, so we are, as we move out of the ELA reading realm, everything else that we're going to be looking at for the rest of the semester is much more concrete and straightforward. And when it comes to assessment, the challenge with reading overall is while there are specific skills that are going to be taught and need to be assessed, identifying a difference between passages, the difference between understanding character at a 4th grade level versus a 10th grade level becomes very, very subjective, right? So while we talked about rubrics when it came to our ELA assessments, any reading assessment is also, or most reading assessments are also going to include rubrics in some way, shape, or form. And you just have this overall air of subjectivity to a reading assessment or an ELA assessment, no matter what you are doing. As we talk about math and then everything else that we're going to be working towards, which is going to be looking at creating our own assessments in general, and graphing and analyzing assessments, this is all much more data-based, objective, a little bit more cut and dry as opposed in terms of what we're actually going to be doing. All right, so this second half is much more direction following than like trying to figure out what the idea that we're trying to uncover is. All right, so it's a little bit, I think, a little bit more straightforward. And as we'll see with math assessments, it's all really cut and dry, including when we talk about applications and word problems at towards the end of today. You'll see that there's not nearly as much gray area in terms of how or what we assess, how or what we score, and how or what we make decisions based off of. All right. So when we are assessing math, we are talking about 4 major components of math. So we have calculation, and with that, we have computation. We have numeracy, we have concepts, and we have application. The only piece in there that I think is subjective at all is the concept of numeracy. And I think that that is more subjective based on the challenge of a definition of numeracy as opposed to the skills that actually make it up. So while it's harder to pin down how you want to look at numeracy, what you have is easy enough to assess. All right. The focus of, within math assessments, the focus of our curriculum-based measurements is going to be on computation, right? Or calculation, both of those. All of the other ones can be assessed through additional procedures, other means. So when we look at math assessment, what we're going to be starting with are CBMs. And then everything else will either be teacher-made assessments, curriculum-based assessments, so those assessments that come directly from the curriculum, or any other means that we have of assessing. So first of all, let's start with what challenges we do face when it comes to math assessment. The first challenge, and this is probably going to be looked at, or probably looked at by most people, not as a challenge, but a benefit, is that there is this massive focus on computation when it comes to assessment. I don't want to put a number on it, but the vast majority of math assessments that you see or give from, in any math class, at any grade, at any level, is going to have some sort of significant focus on, here are these 10 problems, answer them. Not word problems, but just like solve these equations, right? That it's easy, it's valid, but that's a little bit like saying that every reading assessment, the focus is going to be on, can you read these words? Not can you understand, not can you derive meaning, they cannot do anything other than read the words. And as we've seen with reading, after about third or fourth grade, that's not something that is measured to the same degree anymore. It's still there, for sure. But we immediately, it's like a progress check. Can you do this? Great. If so, now we get to the things we care about. For computation and for calculations, those are almost the meat of what we're doing. If you, I still remember in later high school and college, struggling through like those basic calculus tests. And even at that level, at the highest level, it was very simply solve the thing. It wasn't comprehension. It wasn't the application that we'll talk about. It's just solve. The reason for that, like I said, is they're easy to make, they are reliable, they're valid, and it's fast, right? And it gets you the core of what you need to know. Can you do the problem? The additional challenges are that there's a big jump from computation or calculation to application. Being able to solve an equation and being able to use an equation in the real world is there's a huge difference there, right? In reading and in ELA, being able to read the words and being able to understand the words has a much smaller gap, right? If you can't read it, there's a very strong correlation between the level that you are able to decode at and the level that you're able to comprehend at. So if you can't read the words, you don't understand it. If you can read the words, you probably do, right? For math, there's a huge difference between being able to calculate and being able to use, right? That's why we end up from such a young age relying on things like word problems in order to get to give our children the skills they need to be able to apply. All right. Math does have, by necessity, through these application problems, a focus on reading comprehension. I think that is a major challenge of math assessment, right? By second grade, we are teaching our children, probably earlier, we are teaching our children to answer word problems. And at that young age, we are already able to see a discrepancy between our children that are stronger readers and those that are not in terms of what they are able to get out of math. If you've worked with younger kids, you've probably seen that there are those kids that can solve equations, but if they can't read, they can't apply. And now what are you actually assessing? What are you truly assessing? Are you assessing reading comprehension? Or are you assessing math skills? All right. And finally, I think this is personal opinion, the relevance of later concepts. So when you get to higher order math, and when you get to this period of application in even in geometry to a point, which is not so high level, right? The types of application problems that you have to ask are very abstract in terms of relevance to everyday life, right? Yes, there are times where we can use those concepts if you're building something or you're working around the house or you're working on a car, but there's no, in the everyday, the relevance of that is significantly less than the relevance of, say, reading, right? So finding the ways to make higher level math in particular more applicable through meaningful assessment, I think, is a challenge. Are there any secondary math teachers in here? Secondary pupils? No. Hopefully, I don't know if those that are missing today would be able to chime in, but I'm curious about the accuracy of that statement, or what they would say. But what do you guys feel about that? Do you, from your own experiences, through about 6th or 8th grade math, I would say there's lots of relevance, right? But then after that, I don't know, the most relevant geometry lessons I remember, right, and that I use on a daily basis, are when I happen to go out and there's a pool table and I'm thinking about the angles of how to get my ball around the table, right? There's challenges to that. There's challenges of making those concepts and topics relevant in real world ways. Let's talk about computation assessment or calculation. So this is the most straightforward thing you can possibly have, right? You have a page, you have some math problems on it, you give it to your students, you say go, you see how many they can answer correctly. That's a math CBM. At its core, that's a math CBM. All right. Has anyone given that before, either through Dibbles or AimsWeb or anything else? No. Okay. This is what you see in every curriculum. You'll have progress monitoring checks, your fluency minute, your all these things build to that. So there are a number of reliable, valid math computation CBMs out there. The difference between calculation and computation is simply going to be calculation is your basic math facts. Computation are your more advanced math facts. All right. So when you talk about calculation, it's knowing those basic fact families. When you talk about computation, it's adding and subtracting multi-digits, multiple numbers, that kind of thing. All right. So there are lots of options. Very easy. You choose one. Your school's probably already chosen one for you. You run it. They don't take very long, a couple of minutes to administer. They're easy to score. You add up the number of correct digits written depending on the CBM. So like if I have not going to get me very far. If I have 56 plus 93, whatever that answer is, let's say my student gets it correct, there would be 3 correct responses, right? Hundreds, tens, and ones, okay? If you have again, depending on the directions of the CBM, if there is carrying or regrouping involved, and that involves making numeric ticks at the top as part of your process, those may or may not count as well as correct responses, okay? So you read the directions, you count what you're supposed to count, you omit what you're not supposed to. Almost every CBM that I've looked at for math, for computation, counts digits though, all right? The reason for that is each digit is a calculation, right? Each digit is part of the fluency process. If I am trying to assess multiplication, like multi-digit multiplication, and I have multiple rows, part of that process is fluency with addition, right? So I count the marks for row 1, count the marks for row 2, count everything we're grouping, count the marks for the addition at the bottom, and I have my total score. There are validated fluency targets that are out there for calculation CVMs or computation CVMs. So we know per grade how many digits you should be able to write through computation, and we have aims for beginning, middle, and end of every single grade for every type of computation out there. So like I'm saying, there are so many available. It's the probably the most valid CBM that we have, right? It just takes care of itself, which is really, really nice. The strongest part of our computation assessments, and this is why we rely on CBMs, especially for this, is the curricular breadth that they are able to encompass. So what do I mean by that? There are an infinite number of addition problems out there, right? Especially when you get out of your basic math facts. The challenge for us as teachers would be knowing how many questions to ask, what types or formats of questions to ask, and at its core, how much is enough. So if I have, if I'm working on double-digit math facts, really need. Is there a whiteboard marker over there? Where? Why did it disappear? Right here. Great. Okay, so if I have multi-digit addition facts, I need to be able to identify how much is enough of each format of multi-digit addition. All right, so what do I mean by that? I have 23 plus 35. One problem, check. I have 57 plus 24, another type of problem. I have 50, 63 plus 82. And I have, I don't know, 75 plus 96. All right. So what are these different variations? I have 2-digit plus 2-digit, no carrying. Right? 2-digit plus 2-digit, carrying in the ones or regrouping in the ones. Here, nothing in the ones, regrouping in the tens. Here, regrouping in both. So if I'm assessing double-digit addition or multi-digit addition, I have to make sure that I address all 4 of those in my assessment, right? If I add in subtraction, if I add in into the hundreds or thousands, if I add in multiple addends, or more than 2 addends, there are all these different variations that as a teacher in a classroom, I have no way of knowing how much is enough, right? I don't have any means of validating whether or not 5 problems of each of these is enough, 20 problems of each of these, 20 problems across. I don't have any way of looking at that. CBMs have done all that work for us. So when we get a math computation CBM, we should be able to trust that there is curricular breadth. They've covered all of the different variations for the skill that we are looking at in a valid way, right? And with that, we have that confidence that the score that we are going to get is meaningful to the aims that we are trying to set, whatever decisions we need to make based off of that, all right? So there is a lot of simplicity in using these computational CVMs in order for to conduct these assessments. Very easy to make decisions with, very easy to progress monitor, right? You get with anything in math, or most things in math, I'm not going to say anything, you get very clear data with which to analyze, right? You got 4 out of 7 of these types of problems. You got 7 out of 7 of these types of problems. You need to work on the ones that you got 4 out of 7, right? There's no black or white in terms of interpretation, or sorry, it is black and white in terms of the interpretation of the data. There's no gray area. So it's very easy to make curricular decisions based off of these types of CVMs. And it's easy to progress monitor, right? You can trust the score that you have. You know that your next CVM is going to be of equivalent format, of equivalent length, of equivalent difficulty, so that your next concept is, or your next progress monitor is going to be meaningful, directly meaningful to what you're trying to study. When you compare that to reading assessments, you may have variation in the length of the passage, the content of the passage, the background knowledge that the child comes with. All of those things make comparing reading assessments and writing assessments much, much more challenging when it comes to progress monitoring. Again, you're putting your hands or your faith in the hands of those assessment builders, the people that have made those assessments, that they have validated all the different passages, that they've done all the legwork, but there's no real way for you, sorry, a little chilly, for you to evaluate that on your own, okay? So when it comes to computation, don't do any more work than you need to. Don't worry about making your own assessments and trying to come up with all these different problems and hope that you have something covered to the degree that you need to have it covered. Use a CVM. Use a published CVM. It's just going to be easier. All right. Any questions there? Okay. Numeracy, concepts, and application. There are CVMs related to all 3 of these. You can go out, Dibbles is going to assess this, Ames Web is going to have assessments that cover these different components of math. But more than anything else that we've spoken about, I feel that teacher-made assessments for numeracy, for concepts, and for application are appropriate, right? Unlike computation, when we are assessing numerical skills, when we're assessing concepts and application, we're talking individually about very small ideas. When you're looking at a concept like estimation, right? Yes, there is a question of how many is enough, but look, if I ask 3 questions of round to the nearest 10, 3 questions of round to the nearest 100, and 3 questions of round to the nearest 1,000, you either can or you can't do those, right? I don't need 50 different questions, as I might on a computation assessment, to truly assess all the different variations. I need to assess in the ones whether or not you can round if the number is above 5 or below 5. Tens, hundreds. It's just that straightforward, right? Now at each grade level, there are going to be variations to that relative to the targets of the grade level that you may have to reassess on, but it's the concepts are still the same. I haven't seen or come across, at least at the, definitely in the elementary level. I don't want to speak as confidently in the secondary level, but I believe it to be the case. Any concepts that have the level of variation that would require relying on those validated CBMs to really get where you want to be. All right. So when it comes to numeracy applications, or sorry, assessments, the biggest question becomes, what is numeracy? What are we actually assessing? So numeracy itself is a collection of skills. If those skills are present, then we can say that a child has numeracy. All right. It's not a great definition by any stretch of the imagination, but it gives us something to work with. So to me, those skills are related to what I call the fluent manipulation of number. So if you can have a number in your head, break it apart, put it together, change it in different ways, then that is numeracy. If you understand that number can itself be manipulated to do different things, that's what is necessary for numeracy. So looking at relationships between numbers, looking at what is the relationship between 52 and 102? What is the relationship between 26 and 28, right? Thinking of a number grid and how we can talk about how these different numbers are related to each other, all right? So for me, what I would do, my test of numeracy was I would give my kids this was for second grade, so think of still working on addition and subtraction, not getting into multiplication yet, but testing like this basic numeracy. I would give them like this number, and I would say this is a section of a tens number grid. All right. Yeah. And I would say, find this number and give me an equation, either addition or subtraction, that represents this grid. Okay. So what would they have to do? They would have to understand that the relationship here is 1, 2, 3, 13, right? Just go down the number grid. So 47, 48, 49, 59. And then I could say from that, 46 plus 13 equals 59. So they would understand, that would be the visualization of how do I get from number 1 to number 2 through this base 10 structure. Does that make sense? Hopefully that made sense to you guys. Yeah, a little bit? No? So I'm not going to go over it. It doesn't matter. I taught it this way, so they knew what I was talking about. But this was, they would be able to, from that, understand that there was this adding by ones and adding by tens relationship between any two numbers. So if you expand that out to a large number grid, you could, in your head, if you're not fluent in what's 46 plus 13, if you're not fluent in those facts, you would know that I could, in my head, think 46, move over 3 spots for here, 47, 48, 49, down 1 spot for my tens, and understanding how that all worked together, and get to 59. Trust me, it worked. Okay. Again, there's no objective definition of numeracy that we're working off here, so that happened to be the skill that I was teaching for it. But once I have this skill and have it defined, I don't need to ask very many of these questions. It's a component of numeracy. I can see, do you either have it or do you not? All right. Relational value, greater than, less than, or equal to, same thing. you don't need a lot of questions. You can either do it or you can't. Parts of a whole. Give me two numbers that make 56. Give me three numbers that make 24. Can I tear that number apart and put it back together? So these are different types of skills that are encompassed in numeracy. Numeracy itself might be hard to assess. The individual skills are very straightforward. So as a teacher who's coming up with your own assessments, identifying the skills that you're teaching and assessing them to the level of curricular breadth that you taught to is really straightforward. All right. Having a CBM, a progress monitoring CBM for these types of skills doesn't make a whole lot of sense. Okay. When it comes to numeracy skills, when it comes to the concepts that we are going to talk about, when it comes to application, you're not testing the same thing over and over and over. That's why computation fits so well in a CBM framework, while these other skills don't necessarily. When it comes to computation, no matter where I am in first grade through fourth grade, assessing addition and subtraction skills is meaningful. Once I leave kindergarten, first grade, I'm not assessing time skills. Once I leave second grade, I'm not assessing money skills, right? We've learned that concept and it is contained within the grade that it's taught. Now, the underlying skills of addition, subtraction, multiplication, division, addition with fractions, addition with decimals, that kind of stuff, that is what gets monitored. At the end of the day, I care about that computation. I don't care about the use of that computation in terms of progress monitoring. So when it does come to these concepts and application, exact same as we just spoke about with numeracy, identifying the number of problems, the type of problems that are relevant to what you just taught is sufficient to assess the skills that you are targeting. All right, estimation, place value, fractions, decimals, algebraic manipulations, geometric manipulations, all of these can be devised by teachers. All of these can be devised as an assessment tool, or assessment tools for these things can be devised in the classroom to meet the needs of what it is that you are teaching. Now, ensuring that you are teaching the breadth of skills is a different story, right? You have to be looking at standards, you have to be looking at what the curriculum covers to ensure that you are addressing all of those different components. But if you are teaching all of those different components, and then you have questions that assess those different components, you have the data that you need to make decisions on those components, right? There's no bigger picture when it comes to math. That sounds silly, but we're not putting it all together in the same way that we are putting something together like reading comprehension, like writing ability. There's no generic math ability. There is, but it's not a testable thing. Reading comprehension we have made testable. Writing we have made testable. Math we test skills. All right, and because of that, it is that much more straightforward. All right. I think the relationship between concepts, between concepts and application when it comes to assessment is actually a little bit of an interesting one. So application or word problems overall are just those, they're just that, right? They are real world applications of the concept. What you are assessing, especially at the older grades, is not necessarily going to be the understanding of the concept, right? So if I have estimation, right? It's a good example. If I have estimation as a concept, I can test that in any number of ways, right? I can give two numbers, whatever I had, and say, estimate the sum. Straightforward concept. I can have two amounts at a younger grade and say, estimate how many are here. I can estimate there are 50 chairs in this room, right? Just by looking around and taking those educated guesses. When I take that concept, if I'm saying that directly in a word problem, I'm not accomplishing a whole heck of a lot, right? If I say Kevin had 26 M&Ms and Jim had 34 M&Ms, estimate how many they had together. That's not assessing an application of estimation. That is assessing the concept directly, right? I'm telling the child what to do. However, if I, through my assessment, through my word problem, I give a situation that requires estimation, and I say, figure this out, and you have to figure it out by estimating, then I am saying, can you, in a real world situation, use this concept, apply this concept in a meaningful way? All right. What I find interesting about that relationship is that you only need a couple of opportunities to demonstrate for any given concept that you can identify where to use it, where to actually apply it, right? When we at the younger grades, when we give addition and subtraction word problems, we don't say add to find the answer. We just say how many were there or how many are left, right? That's the application question. That's where we're able to challenge the student to figure out what operation to use. There's an assumption there that the child can add or the child can subtract. That concept or that computation has already been assessed. The application is, are you identifying that this is a situation where you use addition, subtraction, multiplication, whatever it might be? When you give those types of assessments, and at any grade, at whatever skill you are targeting, you'll find those kids that get the computation wrong, right? For whatever reason. And when it comes to scoring those assessments and putting in your point values, the first thing that you're going to be asking yourself is, do I care? For this word problem, do I care, or to what degree do I care that your computation is incorrect? What I care about from this question is, did you understand that it's an addition problem? Did you understand that it's a multiplication problem? Great. You're at least getting partial credit, if not full credit. The question itself might be, what computation is necessary to answer this question? And that might be the whole problem right there. At the older grades, what we end up being able to do is rely on these application questions to test the concept as well, right? It's not as clean that way because you are simultaneously testing both concept and application. So if something is wrong, you need to be able to say, yes, you did the right operation here, but you solved it incorrectly, and differentially score those things. But it is easier, or it can be done when you've controlled for things like reading comprehension and calculation to assess both of those simultaneously. All right. But what I hope that you can see from all of this is it's not a challenge to get given a narrow concept range, a narrow set of skills that you are teaching. It's okay to come up with a few questions as your assessment, right? We don't need these bigger, more elaborate assessment tools in order to have an understanding of where our children are, right? When we look at CBMs overall, the pre-packaged CBMs that are widely out there, we talk about the QRIs and the DRAs, to some degree DIBELS and AIMSWeb. The focus is overwhelmingly on reading. The focus is overwhelmingly on reading. And that's because, one, these are easy to create, but two, there just isn't this larger picture that is challenging to assess. Math in general is a very skills-based subject, right? We learn this thing, then we learn this thing, then we learn this thing. And there's relation between those things, but one, until we get into more specific math subjects, geometry, calculus, trig, algebra to some degree, there isn't this building on skills to the same degree that there is in reading, where it's the same skills over and over and over and over that we're leveling up. All right. Any questions? No? Okay. Straightforward today, super straightforward. On Thursday, I think what we're going to be doing is looking at a few different math CBMs, looking at how they're scored, how they're analyzed, that kind of thing. But again, it's going to be pretty straightforward. Okay. All right. That's it for today. Easy enough.